Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 195, I chat with sound engineer Brian McCarty about sound for movies. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded February 20th, 2012. Episode 195, Movie Sound Then and Now. This episode of Home Theater Geeks is brought to you by Scott eVest, technology-enabled clothing to carry all your gadgets. Visit scottevest.com/twit now through February 24th to save 40% off 14 of their best sellers. That's scottevest.com/twit and use the code TWIT13 at checkout. Hey there, Scott Wilkinson here, the Home Theater Geek and Director of Content at avsforum.com. This week's guest geek is Brian McCarty, a recording engineer who works with SMPTE and AES on all sorts of various standards for audio, and that's what we're going to talk about today. Hey, Brian, welcome to the show.
Hi, Scott. Nice to see you.
Nice to see you, too. I must tell everyone that Brian, we are talking with him from Australia, the northeast coast, if I'm not mistaken.
That's the northeast coast of Queensland in a city called Cairns, which is the gateway to the Great Barrier Reef.
Oh, and if you're doing any snorkeling or scuba diving, that's the place to be, isn't it?
Oh, absolutely. And we're just finishing up summer here. This is actually one of the first sunny days we've had in a while because if you look tropical up in the dictionary, it says hot and wet. Well, we've had a lot of wet the last couple of weeks.
Yeah, well, you're not alone. A lot of the rest of the world has too. But anyway, glad to know that. What time is it there, by the way?
It's 9 a.m. tomorrow.
Oh. 9 a.m. tomorrow. Well, here we are in the time travel show. No. It's Home Theater Geeks. Those who are tuned into the live stream at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Brian as we go, and I will pass along as many as I can. So, Brian, you're a recording engineer. You started in music, but you migrated over to film sound. Give us some of the projects that you've worked on.
I started at Warner Brothers Records in Burbank and was on the Burbank film lot. This is the late 1970s, and had never seen anything being filmed before. And the first thing I saw out of my window at Warner Brothers Records was Dukes of Hazzard.
With that great car, I remember that car.
There were a lot of cars.
Yeah, well, yeah.
When I made the jump to the Burbank studios, I spent about a year doing pretty much anything that was on the lot that needed somebody for a day or two. The first thing I worked on was 8 is Enough. I worked on Wonder Woman and The Day the Bridge Fell Down and lots of kind of mid-range television. The first feature film I did in 1978 was Altered States.
I remember that movie.
Then I did The Postman Always Rings Twice with Jack Nicholson and Jessica Lange. And the third picture I did was on Golden Pond, which was a very important picture for everyone that worked on it, and was important for my career at the time as well. But it wasn't long after that I switched to doing musicals, which is what I had intended to do going over there. The first musical I did was Staying Alive with John Travolta, and I did Footloose, Rhinestone with Dolly Parton. I've done 5 pictures with Dolly. Sweet Dreams, the Patsy Cline story. The last picture I did in Hollywood before I left for Australia was The Big Lebowski.
Oh, man. Dude. Now, well, what was your job on all these movies? I mean, you were working on the sound, but in what specific capacity?
Well, I was always production sound. So at the beginning, I was learning how to mic the scenes, how to hold a boom. When I moved into music, I would end up being music playback or the music coordinator on the picture, which meant that we produced the music prior to shooting, and I followed the music through the production process, and when it required either singing or dancing going on. And then everything gets, of course, turned over to somebody else because the jobs are cut up into pretty bite-sized pieces in Hollywood.
Mm-hmm. Now, production sound is recording the sound on the set as they're shooting, right?
Yeah, that's correct. And even when you're doing music or a musical, it's very important to capture the dialogue, and to capture the production dialogue for use in the final mix. Nobody wants to be replacing dialogue if they don't have to. So you develop a lot of tricks that allow the actors or the dancers to hear the music, and yet the music doesn't get recorded with the production dialogue to give the editors flexibility in adjusting the scene.
Mm. I thought that most movies and TV shows, I don't know the percentage, but I was under the impression that most of them actually got the dialogue replaced
Oh no,
in
no.
post-production.
No,
That's
no,
not
no.
true.
Oh, no, no, absolutely not. The
Mm.
the the production dialogue recorders in Hollywood are extremely skilled, and except when you have a movie that has a situation that can't be avoided. For example, special effects where motors are running, or special effects equipment is running and can't be is integral to the scene. Most pictures, the vast majority of dialogue is production dialogue. That doesn't mean that they always use the usable production dialogue. Sometimes they want to make a change in the dialogue line, or the actor didn't do it as well as they could have, or something like that. But
Mm.
to give you an idea, on Golden Pond, uh, every line in the picture is production dialogue. There is one line that's been moved out of another take, but every line in that picture is production dialogue.
Mm. And I assume you must capture the production dialogue with like super shotgun mics or something, because they can't have mics close to them.
There's a wide variety of things that are used. Originally, Sennheiser shotgun microphones were the standard, but there's a lot of work being done with cardioid microphones now, that have better overall sound quality, and it's it and then there's lavalier microphones that have to go on people, for example. It's every shot is a different procedure, and
Mm.
that's, I'm sure, production mixers will tell you, that's the joy of the job, is that it's every day is different.
Yeah. Well, that is a good way to characterize a good job, where every day is different as opposed to every day being exactly the same.
Mm.
So once you now you're in Australia, you moved there because I guess you got tired of Hollywood, or you liked Australia. What was the deal there?
20 years in Hollywood was enough for us. My wife and I are both from Chicago originally, and there was no chance of going back to Chicago,
Right.
as this winter showed.
Yes.
So we started looking around for basically a tropical place. We like the tropical climate. Discovered that there's problems living in Hawaii. There's problems living everywhere. Let's face it.
Everywhere.
But
Yeah.
um, the first time we visited Cairns, we liked it a lot. Um, it's normally difficult to migrate here if you're over 40 years old, but we managed to get through the gauntlet. We've been here about 14 years,
Hmm.
and we love it here.
You're still doing movie sound, or I mean, there can't be
Uh,
that much movie production going on in Cairns, Australia.
No, no, there isn't. For a time here, we had a recording studio. We were doing jingles and TV commercial production, that sort of thing. But about 10 years ago, as the work began at SIPTY for digital cinema, I became very interested in the standards work and the standards process, and decided to devote some of my time to that. And it's actually now 100% of my time is
Hmm.
devoted to the work that I'm doing on standards. And I'm not really doing any recording anymore.
Well, and that's primarily what I wanted to talk about on the show today was your work in the world of standards, uh, because digital cinema, of course, and television abound with standards, are everywhere. And I know that you wanted to talk about how film sound and pro audio have parted ways, and what are some of the problems still with film sound as opposed to pro audio?
Well, in the late 1960s, as we saw really the development of high power professional audio systems, a la Woodstock, the first big high powered music systems tried to use cinema speakers as their PA speakers. In fact, Altic made a kind of quasi portable amplified version of the A4 that bands used to carry around. But everybody very quickly realized that the fidelity of those speakers wasn't very good. And it wasn't good because in the movie theater, they were being fed analog optical sound, binaural analog optical sound for the most part. And those speakers were designed to not have any high frequency production because it was just noise up there off the optical soundtracks.
Hmm.
Uh, but as we moved into Dolby Stereo, of course, it then became necessary to have a higher fidelity loudspeaker in the theaters. And steps were taken at that time to try to put some of that higher technology into the theaters. But
Hmm.
but the Dolby Stereo was still a very bandwidth limited technology. Dolby Stereo was actually engineering work done by an engineer at Kodak named Ron Uhlig. He figured out how to put two optical soundtracks in the same space as the one mono track had existed before. And as was Kodak's uh, uh, plan during those years, any technology they invented, they turned over to the film industry to use or not use. Dolby at that time was thinking about other applications for their noise reduction, and this seemed like a good application of that. That combined with kind of open source uh, uh, plus and minus channel decoding gave us what we know as Dolby Stereo.
In which,
But
just make sure everybody understands, there were one surround channel and one center channel that
exactly.
were matrixed into the right and left channels. They were sort of folded in, combined with the right and left channels, so that they could be delivered in a two-channel format and then extracted during playback.
And that's exactly right. And that was all the matrixing technology was all known science at that point. In fact, David Haffler used to do a lot of experiments with that. But it was a good use of uh, that stereo soundtrack that Ron Uhlig had invented.
Now, when you say optical analog, I want to make sure everybody understands that. Explain what that is and how that was so dominant for so many years in commercial cinema.
There was a space left between the sprockets and where the picture began on a 35 millimeter frame. The space, I believe, was 5 millimeters wide. And there was actually a little squiggly line, which was really not much different than an LP recording, which was a collection of very squiggly lines pushed very close together. And this squiggly line was written during the mastering of the film, and was printed along with the film, and then was decoded, if you will, or read back by an optical sensor on the edge of the film.
Here we see, those of you who are watching the video can see an actual picture of the optical soundtrack, which is essentially the waveform, the audio waveform, aka a squiggly line, sitting there between the actual active movie area or image area and the sprocket holes.
Right. And of course, you always have to remember that picture came first. Sound didn't come along until 40 some years after Edison first began making movies. And the picture people never let us forget it. and we're always struggling to find bandwidth for what we do, to send what the best quality work we can send, along with the picture people, who of course want to do the same thing.
So originally it was one squiggly line. Then with Dolby Stereo, it became two squiggly lines, and those two squiggly lines actually unfolded into 4 channels: front, right, left, center, and 1 channel of surround that went all the way around the back of the theater. And then how have we progressed since then?
Well, then in the late 80s, again, Ron Uhlig began work trying to figure out how to write digital bits on film. About the same time, DTS was developing a system which required compact discs to be synchronized along with the picture. So the DTS system allowed essentially CD quality audio to be carried with the picture. The first digital sound on film was a consortium between an optical radiation company, which is a lens company in Hollywood, and Kodak, and it was called CDS, Cinema Digital Sound. It utilized the same space where the analog track was to carry 5 plus 5.1 full bandwidth digital channels. That system had difficulty getting traction with the exhibitors because it had no fallback position. If for some reason the digital failed, there was no analog track on the film to carry the theaters through. But then we saw very quickly SDDS, which was Sony's version of a system, and then finally we saw Dolby Digital. Dolby Digital, because they were the last people to the party, ended up with the only available space left on the film, which was the area between the sprockets. This area,
real estate was getting pretty crowded by then.
Yes, it was, and up until just several weeks ago, Hollywood was still making these soundtracks that carried 4 audio tracks with them.
Up until only recently?
Only recently, Paramount just announced a few weeks ago there would be no more films distributed.
True, I do remember that.
And I expect to see all the Hollywood studios announce that this year as well. The era
Although
of film
we must point out that really the Paramount announcement anyway was only applied to the U.S. That they were still going to distribute film to other markets outside the U.S.
Sure.
Did I have that right?
Yeah, that's correct. But there are going to be markets where another language is involved, so there will only be one soundtrack on those prints.
Of course.
Some markets like Australia, for example, Australia is 100% digital now. So I imagine we'll see the end of distribution of prints here very shortly, if we haven't already. So it's going to depend on the take up of digital cinema in all of these markets.
Right, which is going to happen. I'm convinced of that. You know, I mean, film, I think, is in its waning days. So
It, it's a better product for both picture. The 4K version is a better product for both picture and for sound,
yeah.
because as we started developing the standards for digital cinema at the SMPTE, uh, several of us involved in sound insisted that it carry full bandwidth uncompressed audio. And we ended up with a system that will carry at the moment 24 channels of up to 96 kilohertz, 24-bit audio with no compression, just standard PCM audio.
Now that's
And
not encoded in the well, obviously it's not encoded in the film because there is no film. And hard disk space is cheap, so of course you could put as much audio on there as you want, even with 4K video, and it should be fine.
That exactly was our argument 7 or 8 years ago when this discussion came up. Of course, proponents of other systems like Dolby and DTS wanted to continue carrying their format in a proprietary way, with the argument that it would save space. But in a 2-hour movie, the space involved for the 24 channels of 96 kilohertz audio is 11% of the digital master. There was never any reason to carry anything but full bandwidth uncompressed audio.
Now, I know that you have attended a number of demonstrations of compressed audio, Dolby Digital, DTS, or whatever, versus uncompressed. And you told me a story about one of those demos that I'd love you to share here.
Yeah, and this is really what so convinced me about the evils of audio codecs.
And by that you mean
Not
lossy compression, right?
a lossy compression, but even so-called lossless compression can have artifacts if codecs are used in a cascaded way. With film sound, the soundtracks are quite often made with multiple studios involved in different elements. If they're all using what they think are lossless codecs in their work, different from what other people down the chain are using, there's known problems that can occur because none of the codecs are evaluated in a cascaded type of way. So I'm really anti codec of any kind at this juncture, because I don't think we know near enough about them, and we're reaching the point where, as far as audio is concerned, I believe the pipe is big enough to carry full bandwidth audio.
Okay, so tell us about this demo that you saw at Universal.
Not long after Dolby Digital came out, the head of the Universal Studios sound department, a terrific engineer by the name of Dick Stumpf, may he rest in peace, organized one night for about 400 sound mixers in Hollywood a demo of a current film where they had extracted the orchestral music and sections of dialogue, those being the easiest for people to identify when they've been tampered with in an audio sense. And we sat in the Hitchcock Theater at Universal Studios with one picture playing, but two soundtracks available on an A/B switch. One of them being the Dolby Digital, the other one being the DTS system. I don't remember when the first switch was made from what system to what system, but it was clearly obvious to 400 sound engineers that the Dolby was missing large portions of the audio, especially at high frequencies. The high strings, the violas were really impacted by the codec that had been chosen to do that system. And 400 sound engineers involuntarily laughed. There wasn't even a question that it was a close call. It wasn't a close call at all.
But DTS is a codec as well, isn't it?
Sure, it is, and I suspect if you put the DTS up against a 48 kilohertz, 96 kilohertz, 24-bit recording of that original music, the 400 sound engineers would hear a difference as well.
Mm.
But and that's a good point, Scott. You know, there's very little subjective testing done on any of these systems before they get launched. And I'm talking about audio systems. Curiously, the picture people all get a lot of chances to look at different codecs and see the impact on their picture. But one of the things that I'm constantly pushing all the standards organizations to do is subjective testing so that we know what the results are.
And this demo was a perfect example of exactly that. That you did an A/B comparison, and it was so obvious what was going on.
It was, and it was so obvious that my understanding was the studio was ordered that demo would never be done again.
I wonder who asked him to do that. Listen, Jovial Brit in the chat room is asking, can you explain the difference between Bitstream and PCM? This is a little off subject, but it's a question that came up in the chat room, and I wanted to get to it before we moved on.
I mean, PCM stands for pulse code modulation. It's a method of encoding a bit stream. So a bit stream is any collection of data that's will be decoded to do whatever it is you've encoded it to do. PCM is a kind of encoding of that data.
Very often when in the home theater realm, we talk about bit streams being like the DTS bit stream or the Dolby bit stream, the encoded bit stream, whereas PCM is unencoded in a sense. I mean, it's encoded in this pulse code modulation, but it is uncompressed. It's the same data stream that comes off of a CD. So I guess I would agree with you that PCM is a type of bit stream, but a bit stream doesn't necessarily have to be PCM.
Oh, that's exactly right. And PCM is the exact electrical representation of the waveform.
In a digital way. I mean, it's electrical representation, but in little tiny steps.
Yes, exactly.
Yeah. Okay. Good. Jovial Brit, I hope we answered your question there. Now, before we continue, and the next subject of conversation is the X curve. Oh, no. But before we get to that, I would like to thank our sponsor for this episode, which is Scott eVest. Now, this is a question that Scott eVest asks. How many pieces of clothing do you have that are actually engineered? Yes, they're all designed, but are they engineered? And Scott eVest does exactly that. They engineer clothing with tons of pockets. You can see on this shirt I'm wearing here, I've got a pocket in my shoulder. I've got one down, a couple of them down at the bottom of this lovely T-shirt. And they're really intended so that you can take along all your gadgets, and unobtrusively as well. I mean, we have tons of gadgets these days, don't we all? I mean, smartphones and various items, headphones and so on. Scott eVest really designs clothes for the person on the go with a lot of gadgets, which we all now have. I have, in fact, in my lower pocket here, a battery pack that I can use to recharge my iPhone when it gets low if I'm on the go and I'm not near a power plug. So it's extremely helpful there. Not only that, they have this patented thing called PAN, Personal Area Network, which lets you string cables from one pocket to another and up to the collar, where you can put your earbuds in, and the wires for the earbuds aren't dangling all over the place. It's really, really super slick. Now, Scott eVest that's the name of the company, but they make more than just vests. They make high-quality hoodies, jackets, shirts, pants, and other items for men and women to carry their gadgets and gear in style. They're engineered with tons of hidden pockets, as I said, which you can keep not only your gadgets, but also your cash and important documents, you know, your wallet, completely safe. In fact, Scott eVest actually has a pickpocket guarantee. I love this. And they'll reimburse you up to $1,000 if you're pickpocketed while wearing one of their products. And interestingly, over 10 million pockets have been sold already and counting. Now, in celebration of the 13th anniversary of Scott eVest, they are running a 40% off sale for 14 of their best-selling items now through February 24th. Sale items includes men's and women's trenches, Scott eVest's new puffer jackets, fleece 7.0, cardigans, bamboo polos, performance T-shirts, such as the one I'm wearing now, and convertible travel pants, which you can quickly change from full length to shorts. I got to try those out, actually. That should be really cool. Visit scottevest.com/twit to check out the great Scott eVest products that you can buy for 40% off during this sale, and be sure to use the promo code TWIT13 at checkout. That's TWIT13 for Scott eVest's 13th anniversary. But you only have until 9 p.m. Mountain Time on February 24th to take advantage of this incredible sale. Now, if you're watching or listening to this late and you missed the sale, be sure to check them out anyway and use the code TWIT13. Scott Jordan from Scott eVest said he would put up other great deals just for the Twit Army, and they feature different sale items daily for 20% off. That's scottevest.com/twit and use the code TWIT13 at checkout. And we thank Scott eVest very much for their support of Twit. Okay, I'm talking with Brian McCarty, and one of the subjects that I know you wanted to get into, and I really did too, was this thing called the X curve. Can you explain to us what that is and why it's a problem?
Sorry. Okay.
Oh,
Sure.
you muted yourself during the commercial. Thank you so much.
Yeah. I wanted to start this first by really starting from ground zero in terms of acoustics. You can't equalize a room.
Oh, look at that.
And I hear discussions all the time among home theater people and about movie theater people on how they're going to equalize this or that room.
We hear about it all the time with automatic room correction in AV receivers and such. They're equalizing the room.
That's
fighting words.
That's the road to hell, let me tell you.
Okay, all right. Even if it is paved with good intentions, please continue.
The X curve was, in fact, when you talk about good intentions, the X curve started with very good intentions. It was brute force noise reduction. The loudspeakers didn't have much performance of over 2 kilohertz. All we were doing was dialogue for the most part anyway from the early mono movies. And the optical soundtrack was mostly noise above 2 kilohertz. So we put in this very steep roll-off curve, with the knees starting at 2 kilohertz, to take all the high-frequency noise out. That was the primary reason for the X curve at the beginning.
Did this work in conjunction with the old-time theater speakers, which you mentioned earlier didn't have a lot of high-frequency reproduction anyway?
Exactly. And in fact, the curve was even more aggressive on the high frequency at the beginning and was originally called the Academy curve. And knowing what we knew about the B chain, what was coming off of the film and what was going into the speakers, and then what the speakers could do, it made sense to roll off all that high-end energy.
Mm-hmm. So, and yet it was... in the early days, that's what they were doing. I guess they weren't EQing the room. They were EQing for the fact that there wasn't really any useful information up in the high frequencies.
Exactly. So then as we moved into Dolby Stereo, E.O. and Allen, who I know you've had on the show, did some experiments at Elstree Studios in London, trying to determine what a high fidelity speaker sounded like in the far field, and trying to match it with the theater speakers of the day is how I understand the experiment.
Mm-hmm.
And the experiment, it was a subjective experiment, and it resulted in what we know as the X curve. Fairly flat response from 60 hertz to 2 kilohertz, and then a 3 dB per octave declining curve from 2 kilohertz on up. While fidelity had improved really substantially once we went to Dolby Stereo, there was still optical noise, and there were still loudspeakers that were deficient at high frequencies, especially when you consider that they've got to push those high frequencies through a screen.
Right.
And
The speakers are behind a perforated screen.
exactly. So, the X curve became the target. The X curve became the film industry's equivalent of the record industry's RIAA curve.
Right. I
There were
remember that on LPs.
right. There were deficiencies in what LPs could carry that could be quantified, and if you produced a record with the inverse of that curve and then use that curve to decode essentially the record, you would get a flat frequency response. That was the same theory with the X curve. The studios would use the X curve to produce the movie. The theaters would have the X curve equalized into them, and then the playback should come out flat. The playback should come out as what the mixers intended you to hear.
So actually, when it was in being recorded in the studio, would it be like an inverse X curve?
No, they were listening to a room that had the X curve applied.
I
So
see.
the mixers never worried about what the performance of the system was. They would make the movie sound like they wanted to make the movie sound. There was a process after that involving getting that information down to optical, which quite often had to the same way as mastering had to deal with high frequencies on the cutters for records.
Uh-huh.
We had the same physical limitation on film, but the mixers didn't worry about what the room was tuned to. All they did was do the best they could, and with the theory that if the playback room had the same X curve, it would come back the same way.
So what's the problem with it then?
Well, it doesn't work.
Can you elaborate, please?
Of course. And it's gotten worse over time. During the Dolby Stereo days, I think everybody was fairly good about adhering to it in the dubbing rooms, in the studios. However, the methodology to calibrate for this curve, which is set out in a SMPTE document called S202, the method involves using pink noise and an RTA, a real-time analyzer. At the time this was embodied in that document, the record industry and the rest of the recording industry had discarded that technique because it didn't tell you what you needed to know about what people were hearing in the room. It was measuring the reverberant field of the room in an unusual manner. And it gave you readings different from seat to seat. In actuality, from inch to inch, the reading using an RTA and pink noise could be radically different. So a whole industry developed in retuning both dubbing rooms and movie theaters where we were always told originally they were being retuned because things had drifted. Well, electronics doesn't drift anymore. Speakers don't drift. The problem was that the way we were evaluating the rooms was completely wrong. So, of course, you went in and it looked different because you put a microphone in a different place, uh, or you used a slightly different pink noise. And then you go back and you retune all the equalizers and make chase it after this mythical X curve again.
And
And
we have some pictures that I think illustrate what you're talking about. Is this the place to put them?
Yeah, this is fine. A few years ago, some European engineers, including Philip Newell, who's a very well-known studio designer in Europe, started doing some testing of these kinds of rooms. This graph that you're looking at here is the response of 9 different commercial movie theaters in Europe that have just been aligned by certified personnel. And you can clearly see, I mean, you can see the red line, which is the target curve, and you can see the response of every theater is unbelievably different.
Way off from that. Yeah, and different from each other.
All different from each other. And in the critical band from 250 to 2K, which is the voice band, it's no wonder we have intelligibility problems with those kinds of curves. So then we look at the second curve.
The second picture, the second graphic that I sent.
Yeah.
Which should come up here in page 2. Keep going there.
That's the body. That's that one there. The bottom.
Oh, that one there. Sorry. Okay, got it.
This is 11 dubbing theaters in Europe, Dolby certified dubbing rooms in Europe that have been tested using not pink noise in an RTA, but using proper FFT analysis so that you can actually see what the performance of the room is.
FFT standing for fast Fourier transform, just for those who might not know that.
Yeah.
Which is a more precise. Am I correct in this? I've looked at RTAs, real-time analyzers, and they analyze the level at certain frequency bands, and then the RTA, or rather the FFT, fast Fourier transform, analyzes individual frequencies across the range. So is an FFT simply a more finely granulated RTA?
Well, in one respect it is, you're correct, but the other respect that's more important is it allows you to look at the time window, so that you're looking at what the speakers are contributing to the room and not what the room is contributing to the room sound. It used to be thought 40 years ago that what the room was contributing, of course, is very important. And you've had acousticians I know on the last few weeks who've talked about first lateral reflections, for example, and their contribution to fidelity and intelligibility. The problem is the RTA method lumps everything together into this blob. And what you really want to do is take an intelligent look by time of the first, maybe the first 100 milliseconds of what you're hearing, because that's really, your brain is going to ignore stuff that's not relevant. It's what you hear in the first arrival and those very short arrivals after that that's going to be critical to the fidelity and to the intelligibility of the room.
Got it. Okay, so are we still using the X curve today, even with digital audio in digital cinema?
Well, on paper we are.
Uh-oh.
The entire X curve system has broken down. It's broken down for several reasons. SMPTE will soon release a paper where Hollywood dubbing rooms have been measured, much like what Philip Newell has shown in Europe. And we're going to see that the Hollywood dubbing rooms aren't following the X curve anymore either.
Hmm.
And the reason for that is, I think it's twofold, really. One was once they started producing digital distribution masters, they knew that that nothing was going to be hidden in the theaters ultimately, and they needed to make their dubbing rooms sound like every other recording studio. Keep in mind, music recording studios don't use a target curve for the room. Live sound doesn't use a target curve for the room. It's only in cinema where we have this artificial choke on the system,
which was based upon limitations that no longer apply.
Exactly right. Exactly right. And that was why when we started pushing forward with digital cinema, one of the longtime committee members on the Cinema Audio Committee at SIPTI, John Ergel, may he also rest in peace, came to me and said, "Now's your time. This is the time that we need to open everything up to be part of the rest of the audio world." Well, the dubbing rooms in Hollywood already figured that out. They've got directors that come in from their cars where they're playing the soundtrack of the movie on some very expensive car stereo, a Bang& Olufsen or Lucasfilm or whatever is in their cars. And they come into the dubbing room where if the X curve is implemented, sounds dull and all the high frequencies are missing. And it's competitive pressures more than anything else that have caused the studios to abandon the X curve.
And probably a good thing too, huh?
Well, it's not a good thing at the moment because we don't have a standard that anybody can follow, either at the dubbing room end or the theater end.
Well, wouldn't the standard be, sort of flat frequency response all the way out to 20K?
That would be my dream. There are a lot of forces pushing back against that. That's all I can tell you.
One problem is that each room, each theater, each dubbing recording studio and dubbing stage has somewhat different acoustics. So how do you handle that?
Flat is flat. People are putting in loudspeakers that are easily capable of doing flat response in a dubbing room, with the exception of the fact that if you measure at the console, of course there's going to be a slight roll-off due to air absorption and due to what the screen is doing. But this willy-nilly cranking in of unnecessary equalization to chase an artificial target using tools that are 40 years behind the times has resulted in a chaotic situation in the theaters, and a lot of the complaints that we're getting today about lack of intelligibility and overly loud movies relates exactly to this problem, that there's no standard in place.
And therein you enter the picture with working with SMPTE and AES on standards, and that's what you're spending all of your time doing now, huh?
Exactly. And in part, I do it because most of the standards organizations are dominated by companies that have interests in the work that's being done. Of course, that's why they're there, and I'm sure they all want to do the best they can, but they want to do the best they can for their company's goals as well. I see myself as representing the production end of Hollywood. And we have cinematographers on some of the committees that are in the same position. They don't work for any one commercial entity. They're there to get the best picture they can out of the system. And so that's really now driving all of the work that I'm doing, not just here, but at AES, where I'm the chair of the Sound for Digital Cinema and Television Committee, and now at the ITU, which is the International Telecommunications Union, because we have an opportunity now, as we talk about UHD TV, to integrate all of the sound systems into one format. You mix the film once in Hollywood in immersive sound, whatever immersive sound system you like, that Bitstream will carry through the entire process to your home, where it's rendered into whatever your home system is set up to do.
And that brings us to the final topic of conversation today, which is immersive sound formats. We know, of course, of Dolby Atmos. We know of Oro 3D. We know that NHK in Japan, the Japanese broadcasting company, has demonstrated a 22.2 channel system, which is not for digital cinema, by the way, but for UHD TV. So what can you tell us about the push towards immersive sound?
Let me kind of summarize the situation with the current systems. I was at a demo at NHK a few weeks ago. NHK was the first to the party on this idea of immersive sound. And the engineer who did most of the work on this system at NHK, a man by the name of Kimio Hamasaki, is a brilliant scientist and really understands how humans hear motion with sound. The system there was designed for really in support of their television system, and it wasn't designed for cinema at all. Their system doesn't use objects, it only uses channels.
Which unlike Dolby and now somewhat Oro, which are object-based, which means you take individual objects and place them in the 3D sound space without regard to what channel it might be in.
Right. And as you said, Oro originally was also a channel-based system. Well, they've used a DTS open source product called MDA, multidimensional audio,
right, which we've talked about on this show before.
They've used it to implement objects into an Oro soundtrack as well.
Mm-hmm.
I would guess that NHK is going to have to follow the same road, because while they can rely a lot on Japanese programming, a closed system, I think they know that they would be better suited long term to have a system that had been implemented in as widespread a way as possible. The Dolby then is an object-based system, but it uses a proprietary encoding scheme, I guess, to send a soundtrack to the theaters, and it then needs decoding at the theater end. SMPTE has an immersive sound committee now attempting to harmonize the distribution method of all of these systems. The reason for that was really very simple. A letter that came from the North American theater owners and a couple of the European countries to the standards organization saying, we're not going to buy any immersive sound until we know we can buy one system that will last. We don't want a standards war.
Yes, and they're right to do that, because as we've seen time and again, standards wars, format wars, do nothing but hurt everybody.
Exactly, and to their full credit, that was one of the best things they could have done for this film industry and for television now as well, because they've told everybody, nobody's getting our dollars until we know we're investing in something that's going to last us. So that's brought everybody some grumbling to the table. and work is now being done to harmonize these systems. It's technically possible to do this. I have no doubt, understanding the engineering involved. This is all technically possible to do.
Mhm.
The second issue with immersive sound, though, that I think is really important and hasn't been addressed is this issue of what does the audience actually hear? One of the proponents in their advertising says, as you would guess they would say, everyone now hears what the sound mixer heard. Well, that's categorically impossible. And anybody that knows acoustics knows that's impossible. There's two issues to look at with this. One is uh, uh, the bulk of Hollywood soundtracks are made up of invented sounds, sounds that people have no reference for in their life. Even the sound of a jet going overhead, and very few people have stood at the end of a runway and listened to that. So, those sounds really can do anything to the audience, can do different things to different people in the audience. And I would guess that the audience comes out thinking they had a better experience because we couldn't do those things before. Uh, the bigger issue is going to be uh, uh, timbre effects on music and dialogue, especially as you move those elements around. And those are going to be significant, and those are going to be easily heard by an audience who knows what musical instruments sound like and who knows what voices sound like. You've had Bob Schuline on your program before.
Indeed.
Bob is, I mean, Bob is this brilliant retired engineer from Shure, who I know from my Chicago days. That's how long I've known him.
Wow.
And he's really the guru now on his company is called Immersive, on binaural recording and reproduction. Well, we've started doing an experiment. We've been binaural recording immersive sound films from several seats in the auditorium. Ultimately, with the goal to also record the same clips sitting in the mixer's chair where the movies were made.
Addressing the issue of, can the audience hear the same thing that the mixer did?
Exactly. And is the audience, is all of the audience hearing the same thing? And is some of the audience getting an experience that's less than desirable? I would opine that with some of the systems, because the immersive speakers are playing so loudly to do the sense of immersion on the other side of the theater, if you're sitting underneath one of these speakers that happens to be playing loudly at any given moment, that's all you're going to hear. I know that for a fact, and we don't. This is an experiment that's going to take some time and is going to take some cooperation from the movie studios. But if you're buying a new technology like this, don't you want to know what it's doing to the audience? I do.
I would, absolutely. You mentioned binaural recording, and I wanted to just touch upon that for a moment because I got a chat room question a while ago from SoundPro69, who asks, I keep wondering why, with the proliferation of multi-channel and repurposing strategies, I've never heard of establishing a two-channel set of binaural content, especially when you consider the huge number of people listening on headphones. Well, that wouldn't apply to a commercial cinema unless you gave everybody who walked into the theater a pair of headphones. But it certainly could apply to the home market.
Oh, and we hear at the standards level, we hear from proponents of that kind of idea quite often from the games market, where some of that binaural recording is done and given to the gamers. I talked about earlier about trying to develop a common soundtrack that goes everywhere. I really mean everywhere. I mean to your iPad, to your iPhone, to the I things that we don't know are coming down the pike.
Hmm.
All of those devices shouldn't be getting new mixes, shouldn't be getting uh, uh, a time consuming process to deliver them to you. They should be getting one mix that gets rendered down to your device and its capabilities.
And is this what Bob is working on with his Immersive?
Uh, 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 yeah, I can't speak for Bob, but
Oh,
Bob's
no, of
got
course.
uh, Bob Bob Bob's on the forefront of everything that's happening with binaural recordings. You can bet.
Well, then I need to get him back on the show to have it. Well, I'd love to have a show about binaural recording, which is something that I actually did in college and found very fascinating. Basically, just for those who don't know, it's taking a dummy head with very carefully designed ears, putting little speakers in the ears, and recording whatever you're recording with that setup. It's intended to reproduce how we hear 3D in the world in a headphone recording, but it requires headphones to hear properly.
Well, and it's gone substantially further from what you've described. We don't use dummy heads anymore. We use real heads.
Oh,
Uh,
you stick microphones in your own ears, in other words?
and the transfer function of your ears is taken into account. It's
right,
far
because your
more,
ears are very different than mine. So it used to be that dummy heads used these very carefully designed fake ears that were sort of a conglomeration or an averaging of many people's hearing, so that it would sound something like what they actually hear in the real world.
Yeah, no, but with the size of microphones that are being used in hearing aids, for example, now being so tiny and computer addressable to where you can control their frequency response easily, it's amazing what Bob Schuline has done with binaural recording, and I urge you to have him on.
I will. Let's see. SoundPro 99 also says, the problem with object-based system, in my humble opinion, is the glorification of pan-potted mono. Channel-based systems try to bring back the vectorial sound field rather than just send more amplitude one way or another. How would you respond to that?
Oh, that's going to be very true as everybody shakes out these systems and finds what works well and what disturbs the audience. When stereo was first started in Hollywood, of course, people were panning the dialogue with the actors, and quickly realized you can't do that. In 1988. I was in Beijing when they got their first Dolby stereo encoder and sat with the mixers in the Beijing film studio to make their first stereo movie. And of course, they were panning the dialogue. And, I pointed out to them that we really don't do that anymore in Hollywood. And they says, yeah, we know, but, we have to learn our own way.
So. Certainly, there's a learning curve to these new immersive sounds and so on. So, one's got to cut them a little slack. I felt the same way about early multi-channel music recordings, where they just had a cowbell coming at you from the left surround. And, now multi-channel music recordings are much better, much more cohesive, and they create a much better sort of sound stage than those early attempts.
Of course. And what all of this move to immersive sound is going to do for the movie theaters is, I think, very soon you're going to see manufacturers abandoning the old bass bins and giant horns and things, because a company like JBL has in their kit much higher fidelity, higher power loudspeakers in a much smaller package that can be put behind the screen. When I heard the NHK demo a few weeks ago, I was awestruck at one of the clips they played, which was an opera recorded with a single camera from just inside the proscenium, where the actors singing walked across the stage, and the sound never changed timbre from one speaker to another. You never heard where the transition was made. I've never heard that in a movie theater ever in my life. And the reason they were able to do it is because they were using high fidelity, really high fidelity, high quality speakers instead of these old constant directivity horns. So we're going to see a whole learning curve, the whole industry, as we all figure out how to do this better. And that's what the standards process is supposed to do. Set a goal for everybody to where we have to get to. And we haven't done that for 40 years.
Well, then it's about time. And I'm really glad that you're on the case. We've come to the end of a fascinating hour. I want to thank you so much, Brian McCarty, for being here all the way from Australia. I guess it's morning your time, so you get the rest of your day.
Yep. It's Friday morning at 10 o'clock.
Thanks so much for being here. I really appreciate it. Great conversation.
Thanks for having me, Scott.
So Brian's website is coralseastudio.com. Not that he's doing much recording these days, but you can find more information about him there, at least his recording work. You can find me at avsforum.com. You can email me at scott@twit.tv. And you can follow me on Twitter at htgeekscott and also at avsforum. You can always find previous episodes of Home Theater Geeks right here at twit.tv/HTG or on our YouTube channel, youtube.com/twit Home Theater Geeks. Next week, my guest geek is scheduled to be Ron Williams, an industry consultant who will have just gotten back from the annual Hollywood Post Alliance Tech Retreat with news about all the latest entertainment technology, which should be quite fascinating. I do hope you will join me for that. Until then, geek out.